So in the previous video, we talked about how to solve a system of equations with graphing. You just find where they intersect. But sometimes equations are not so easy to graph. Like I would have to solve both of these equations for y in order to graph them, and that wouldn't be the best option. So there are two other ways to solve a system of equations. One of those is called elimination, and that's what we're going to get into today. We're supposed to do this in middle school, but you may have missed it because it was at the end of the year and COVID. So we're gonna do it now. It's in the algebra standards too, so normally we just repeat it. But okay, so here's how elimination works. Basically, we are going to try to eliminate one of the variables so that we can solve for the other one. Like, I'm not going to be able to solve for both x and y simultaneously. But if I could just get rid of the x's for a second and just solve for y, that would be helpful. And we can do that by adding the two equations together. It's going to work out in this problem because if you notice, what happens is if I add them together, negative 4x plus 4x is 0. The x's go away. And negative 2y plus 8y is 6y, just combining my terms really. And that equals negative 12 plus negative 24 is negative 36. And now I have eliminated the x variable. That's why it's called elimination. Now to solve for y, I could just divide by 6, and y is negative 6. That's not the full solution. To find the full solution, I also need x. So pick one of the equations, it doesn't matter which one, plug in negative 6 for y, and then you can find x. I'm going to pick this one because it's got a few more positive numbers. So 4x plus 8y equals negative 24, except in the place of this y, I'm going to put what y actually is, which is negative 6. So now I've got 4x plus negative 48, or just minus 48, equals negative 24. Add 48 to both sides. And then divide by 4. And x is 6. So that is my solution. 6, negative 6. You may want to, this is fine, but if you want, you could combine that into an ordered pair. 6 is the x, so it goes first. Negative 6 is the y. So either way. All right, I want to mention, why are we allowed to do this? Why are we allowed to just add the equations together? This is actually the addition property of equality, which is as long as you do the same thing to both sides of the equation, it's a legal move. And that is what we're doing here. So I added negative 12 to this side of the equation. Remember, this is negative 12. That's what the first equation told me, is that this literally is negative 12. They're equal, they are the same. So if I add this to this side, and I add the negative 12 to this side, I'm adding the same thing to both sides of the equation, and I'm not changing anything down here. So that's kind of why this works. So now the question is, what happens if they don't quite match up nicely like this problem did? So we can handle that. Let me show you another example. This one, if I tried to add y plus y, I would get 2y. So here's what we'll do. It would be really handy if instead of a positive y, that was a negative y. So let's make it a negative y by multiplying by a negative 1. But if I'm going to multiply this by a negative 1, I'll have to multiply everything by a negative 1, which will give me positive 3x, a negative y, and also this gets multiplied by a negative 1. So now it's positive 5. This first equation I'm just going to leave the same. Okay, and the reason that was helpful, I just basically made this a negative y, because now I can add them up and eliminate the y's. And so it doesn't have to be the x that you eliminate. You could eliminate either variable. y plus negative y is 0. 8x plus 3x is 11x. And negative 16 plus 5 is negative 11. And now I've eliminated the y variable. So I'll divide by 11 on both sides and get x equals negative 1. Now I will still need to go back and solve for y. You could use this equation, or even this one. But just pick one of them, doesn't matter which one, and solve for y. I'm just going to use the first one just because. So 8x plus y, which is negative 1, equals negative 16. And then solve for x, so add 1 to both sides. 8x equals negative 15. And divide by 8. And so x equals negative 15 over 8. So that's my x value. Oh shoot, I did this wrong. So sorry. This was x, so plug it in for x. So do 8 times negative 1 plus y equals negative 16. There we go. So negative 8 plus y equals negative 16, and then add 8 to both sides, and then y is negative 8. There we go. If you do like I just did and make a mistake, that's okay. Remember, you can always check your work by plugging in negative 1 for x, negative 8 for y, and make sure that it works. Does 8 times negative 1 plus negative 8 give you negative 16? It should. And it also has to work for this one. Does 3 times negative 1 plus negative 8 equal negative 5? And it should. Okay. So let's do another example here. On this one, again, I have to eliminate one of the variables. And so I'm going, if I can't immediately add them up and eliminate, I'm going to need to multiply one or both of the equations by some number so that I can eliminate a variable. Since this is 10x and that's 5, maybe if I multiply this one by a negative 2, if I multiply by a negative 2, that would make this negative 10, which would cancel with the positive 10. So that's a good option. So negative 2 times 5 is negative 10x. Negative 2 times 2y is negative 4y. And negative 2 times this 4 is negative 8. I'll add that to the bottom equation. And let's see what we get. This one's a little weird because negative 10x plus 10x is 0. Negative 4y plus 4y is also 0. Somehow I have eliminated both variables. And negative 8 plus negative 4 is negative 12. Okay, this happens sometimes, and that's okay. Does 0 plus 0, which is 0, does 0 equal negative 12? No, definitely not. This is not true, and if you ever get to something that just isn't true, there is no solution. This means there actually was no x and y combo that would make both equations true. It's just not possible. This would be one of those scenarios where the lines are parallel and they never actually touch. So if you ever get down to something that is not true at all, there's no solution. If you ever get down to something that is true, something like 0 equals 0 or 12 equals 12, something that's like, well, my variables are gone, but this is true, that means there are infinite solutions. Basically, the lines happen to be the same line, and so there's infinite solutions, if you ever see something like this. All right, let's try another one. On this one, we're going to need to rearrange a bit. In order to do the whole elimination thing, we need the variables to line up. And so I've got my x and x lined up, but I need to move the 2y over so it lines up with this y. So I'm going to subtract 2y from both sides. to get it over there. And so now I have 3x minus 2y. Now it lines up with the top one. Still though, if I were to try to add these, nothing's going to eliminate. So I'm going to need to multiply one or both of them by some number so that I can eliminate a variable. You have a couple options here and it's going to be kind of annoying. Maybe I can make this like 15 and negative 15, or I could make this 10 and negative 10 or something like that. It doesn't matter which one you go with. I'm maybe just going to do the 15 just because that's what I picked. Like if I multiplied all this one by a 3 and this one by a negative 5, then I could do 15 and negative 15. So let's do that. That's going to give me 15x minus 15y equals 30. Don't forget to multiply this side by the 3 too. And then negative 15x on the bottom. Negative times negative is positive 10y and negative 10. Okay, so now I can add them up. 15 minus 15 eliminates the x. Negative 15 plus 10 is negative 5y equals 20 if you add up 30 minus 10. And now I can just solve for y. So y is negative 4. That's half of my solution. Now go back to literally any of these versions, plug in the negative 4 and find x. Let's see if I can do it right this time. So 5x minus 5y, which is negative 4, equals 10. So 5x plus 20 equals 10. Subtract the 20. 5x is negative 10. Divide by 5. And x is negative 2. Again, you should be able to put in negative 2 for x and negative 4 for y in both of these equations and make it work. All right, we have one final example. On this one, I could do the whole 15 and negative 15 thing again, or I think I can make this a positive 4 to cancel out the negative 4 if I just do a negative 2. Negative 2 times 5x is negative 10x. Negative 2 times negative 2 is positive 4y. Negative 2 times negative 6 is positive 12. And I'll leave the top equation the same. And now the y's will eliminate. So add them up. This would be negative 7x, the y's are gone, equals 12 minus 5 is 7. Divide by negative 7, and x is negative 1. All right, now to solve for y, go ahead and, again, plug this into either equation. I'll just use the top one. So 3 times x, which is negative 1, minus 4y equals negative 5. So negative 3 minus 4y equals negative 5. Add 3. Divide by negative 4. And so we actually get 1/2 for y, or 0.5. So that's the y. This is the x. Again, if you want to put that as a coordinate, the x goes first, the y goes last, and this is fine, or separate answers are